worked really hard at the end of the day, and let's say you're a scientist and you gathered some of the data of, let's just say, with respect of weight to the chance of you getting diabetes. So let's just create an X and Y graph real quick. And let's say this is the Y will be the chance of getting diabetes, and the X will be the weight itself. So let's just do percent of getting diabetes, and then this one X would be weight, and let's just say this is our data right here, right here, right here, right here, right here, right here, right here. So you look at this graph and you determine that a best model that fit for this kind of data would be a linear regression model. And let's say you do go with a linear regression model. So you're trying to create a model that goes through the data and has a near to zero loss function and accurately predicts the chance of you getting diabetes based on your weight. So let's just do that real quick. So it's gonna be really hard trying to figure out and eyeballing it. So mathematicians have came up with one solution, and this line of best fit. Now, what does line of best fit do? Well, it is a strategy used to find a line that best fits the data, a really good regression model that accurately predicts and has a loss function close to zero. So let's get started with it. So for the line of best fit, we need to at least start with a line. We need to start at least with a line, right? So you can pick any line you want, and that's fine. But my go-to option is a horizontal line because it's really easier. So let's say this is y equals b. Now y equals b is a horizontal line would be a worst model for a regression model because it's cutting half the data, and to find the loss function of this model, we just gotta calculate the residuals. So let's just calculate the residuals real quick. Just draw lines. So the residual of this would be residual will equal to b, whatever the value of b is, and then y1. So at x1, y1, we just do that minus y1. I don't know why that's there. Then we sum that with b minus y2, the y value, the second point, and then we keep going on until we reach the nth term, yn. So from this seems like you can accurately see the loss function of this model, but this is actually not an accurate way of finding the loss function for this model because since you're splitting half the data, or you could be splitting half the data, it's actually wrong because right here the values will be negative and the values right here will be positive. So what do I mean by positive negative is if you put it through right here, b minus y2 y1, you just get a positive. But if you pick a point up here and you do b minus that, you get a negative. And there's a chance that it might each cancel out zero, and we already know a horizontal line is not a best fit for this kind of linear regression model. And if we use this formula only, there's a chance where the residual might be zero, which we know is not true, or it might make this model look like it has a better residual than it actually does. So what the mathematicians have done over time was they created the sum of squared residuals. Originally, originally they tried finding the absolute value for the residual for the residuals, but apparently they found out that it was just too much work and it messed up the equation a lot. So they just decided to stick to the sum of squared residuals. So it's basically just this equation, b minus y1, but we square it, and then you just do that with every other until you reach the nth term. And yeah, so then once you find out this, you tweak the line a little bit as much as you can, and you try to find and you map out each of the residuals. So this would be like 10, and this would be like 14, let's just say. And then from there you can do a times x1 plus b minus y1. This is another way of trying to find the a and b values for a line. A line is a times x plus b in a linear regression model. So we're just going to use this. We just input everything. We just input the x and y values of each data point, and you can like tweak the a values and b values in a way for it to fit. Then so it's just basically this, except without the b, and we're just using the real function. And this would create another function which we commonly use in machine learning mathematics, and that is the orientation of the line in respect to the sum of squared residuals. Or I think it's the other way around, my bad. But honestly, the x values would be the orientation of the line. So what do I mean by the orientation of the line? Well, what I mean is basically how the line is looking right now. So if the line is like this, the sum of squared residuals will be right here. If the line is like this, then the sum of squared residuals will be right here. The line is like this, that, it creates a model. It kind of looks like a quadratic model, but I don't think so. But I don't think it really is. But so far, this is how a model will look like. And you can just straight up eyeball which orientation of the graph is actually the best fit for this model. But what a common practice that mathematicians use is finding the derivative of each point, sum of squared. You find the derivative of each point, and whichever point has a slope of 0, slope equal to 0, is the best fit for this model. So let's see right here. That means it's this. So if we were to clear everything out, we would say this line is the best fit.